So, today we're going to be seeing trig identities that have things that are bigger than a squared. A fourth power, a sixth power, and eighth power. When that happens, you know, none of our trig identities have fourths, so you're probably going to want to factor something out. So at the top I just have us, let's review how to factor out a GCF just from algebra. What would the GCF of this expression be, this trinomial? It's the greatest common factor between all three terms. Just x. When you factor out, you are unmultiplying, which is dividing. So we'll divide each term by x. So we'll be left with inside x squared plus 2x plus 5. Now if this were factorable further, we would, but it's not. We don't know any numbers that multiply to 5 and add to 2. It doesn't exist. That's it. What's the GCF of the second expression? 2x squared. Again, it's something that you can take away from each of them. When you factor out a GCF, you do not get rid of it. It just goes outside of a set of parentheses. Again, you're undistributing it. So whenever you divide fourths and halves, remember the exponent rule is to subtract those, which would get me x squared, minus, these would actually just divide out to get me x squared minus 2. That's our final answer, just not factoring. Basically, that's what we're doing today, but we'll see secant squared, tangent squared, sine to the fourth. You're going to take out a GCF, and then usually once you take out a GCF, you'll be left with an identity, like one of our Pythagorean identity shortcuts. All right, so establish and prove this identity. Again, the thing that's going to indicate that you're factoring is this fourth power. Okay, if you see a fourth power, we don't have anything that's fourth on our sheet, so we're probably going to factor out something. So we're going to do a GCF on each side. So on this side, the GCF would be cosecant squared. On this side, the GCF would be cotangent squared. So you're going to take a different GCF out on each side. Again, to divide it out, or factor it out, you are dividing and putting it outside of a set of parentheses. So again, use your exponent rule, subtract. 4 minus 2 gets me 2, so this would be cosecant squared theta minus, these would actually divide out, leaving me with just 1. Bring down your equal sign. On the other side, do the same thing. We'll factor out a cotangent. Now I'm just going to do this to save time. Put a big division bar, but I'm dividing each of the terms by cotangent squared. So 4 minus 2 will leave me with the cotangent squared. Plus cotangent squared divided by cotangent squared is 1. Then we go to look for our shortcuts. So we're looking at this, and seeing what those might be equivalent to in our formulas. Now, some of them we may need to rearrange. So the cosecant squared minus 1 is this one, but they have subtracted 1 from both sides, which tells me that cotangent squared theta equals cosecant squared theta minus 1. So this is really the cotangent squared. Okay, bring down your equal sign before you start changing anything else. See if the left side ends up coming out to be the exact same. We'll have cotangent squared times cotangent squared plus 1. Cotangent squared plus 1 is the cosecant squared. You can actually stop and give yourself a check mark. Left side's equal to the right side. Cosecant squared, cotangent squared, cosecant squared, they're commutative, that's done. If you really want to take it further, you could divide both sides by cosecant squared, get cotangent squared equals cotangent squared, but that's it. That's all you need. Okay, the next one is different. The next one doesn't have any fourth power, it has squares. What do we call the number in front of this in algebra? If we have 2x, what is the 2 called? A C.
Coefficient.
Coefficient. Very good. Coefficient. So a coefficient will tell you how many times that's being added together. So just like off to the side, if you were to see 3x in algebra, that's really x plus x plus x. That's 3x. Okay, so a coefficient is telling you like how many times it's being added. So if you see 3 times sine squared, that is really sine squared plus sine squared plus sine squared. We're not factoring here because we don't have any powers higher than 2. Now we also have 2 cosecant or cosine squared. So that's really cosine squared plus cosine squared. On the other side, I'm just going to leave everything the same. I'm not going to change anything. So that's 2 plus sine squared. And then remember, we know that sine squared plus cosine squared is equal to 1. So I can take one of the sine squared, one of the cosine squared, and that's going to be 1. Cross them off. Take another pair. Sine squared plus cosine squared is 1. Cross those off. And then we're still left with one remaining sine squared, which makes sense because on the other side we still have a remaining sine squared. So we're done. 2 plus sine squared equals 2 plus sine squared. If you wanted to, you could take it further, subtract 2 from both sides, whatever you want to do. But as soon as you get the left and right equal, you are done. And then 2a on the back is the only other nearly new one. All of the other ones are kind of repeat problems. This one is similar to number 14 on the packet yesterday. Some of you struggled with where I told you just cross multiply. And this is one of those problems. So right off the bat, I don't see any shortcuts because I don't see any squared. You have to remember these Pythagorean identities only work for squared. These you can attach squares on however you see fit. But you cannot tell me that cosecant minus cotangent is 1, okay? Because that's only if it's squared. So instead, what we're going to do is we're going to try to simplify this mess. When nothing stands out to you as being like an identity, I would change to sine and cosine. And see if we can get some stuff to cancel out. Okay? So cosecant is 1 over sine. So let's change this to be 1 over sine. Cotangent is cosine over sine. Now on the other side, everything's already in sine and cosine, so I'm just going to leave that as is. Now, in order to add or subtract fractions, we need to have a common denominator, right? This has a common denominator, so we don't have to make one. All we're going to do at this point is we're going to make this into one fraction. All with a denominator of sine theta. Okay, so in the numerator we'll have 1 minus cosine theta. Now again, make sure you don't make the mistake of thinking 1 minus cosine is the sine. 1 minus cosine squared is the sine squared, but we don't have squares, so we can't use the shortcut. So at this point, nothing cancels out. You cannot just do this because they're on opposite sides of an equal sign. Okay, if this were multiplication, then yes, those would divide out, but it's an equal sign. At this point, you have to cross multiply, which is just kind of funny because I'm cross multiplying in geometry today too. So it doesn't usually happen. Same thing in the same class, but they're not using trig functions. Now, to cross multiply, we have binomials, things being added, subtracted. Group them with parentheses. So I will multiply diagonally. So 1 minus cosine times 1 plus cosine. Bring down your equal sign. Multiply the other diagonal. Sine times sine is sine squared. FOIL the left side, yep. And we know the middle stuff's going to cancel out, right? But if you want to show it, 1 plus cosine minus cosine squared. I just left off the thetas, just a shortcut. Again, because you have the difference signs and they're the exact same binomial, the cosine, positive and negative, go to 0. I'm going to come up here because I can see some of you are having trouble seeing in the back. So at that point I have 1 minus cosine squared equals sine squared. And if you have the shortcut written on your paper, you can just say this is the sine squared equals sine squared. Or if you don't have that written on your paper, you can use inverse operations to add cosine squared. And then you do have your identity exactly as it's written on your paper. So you'll get 1 is equal to 1. But again, if you have this written, you can just stop here and say sine squared equals sine squared. Okay. The next one is just like a repeat of basically this one we just did. You would just FOIL it, so we're not going to do that one. And let's just go ahead and save the closure problems for our bell ringer tomorrow. We'll do those. It's a little warm up. So your homework is to complete 3 problems and 3 problems only, 35, 37, 39. That's it. We'll be